Good morning, students. This is video number 3. The lesson is Pli block elements. And this video we are going to see 3 subheadings. The first one is diborane preparation, properties and structure. And the second one is boron trifluoride preparation and properties. And the third one is aluminum chloride preparation, properties and uses. So, the next first one, diborane preparation. So, how to prepare diborane? Diborane can be obtained in small quantities by the reaction of iodine with sodium borohydride. See the first equation, it is given as 2NaBH4. This is only known as sodium borohydride plus iodine. In the presence of decline, it gives diborane B2H6 plus 2NaI sodium iodide plus hydrogen gas. Another method of preparation, on heating magnesium boride with HCl, a mixture of volatile borons are obtained. See the equation down, 2Mg3B2, that is magnesium boride, plus 12 hydrochloric acid HCl gives 6 MgCl2 plus B4H10 plus H2. This B4H10 once again reacts with hydrogen and gives diborane. The formula is 2B2H6. So, these are all the two methods of preparation. The next one is, we can see the properties. Diborane is a gas, it is extremely toxic, that is poisonous, and it's highly reactive because it has low thermal stability, therefore it is highly reactive. There are some 6 reactions given down there. Each one takes place at different temperatures. For example, the first reaction, diborane, when it is taken in a U tube, 388 Kelvin, it gives 2B5H11 plus 4H2. This is a type of borane. Similarly, we have so many other types of borane. If you see down, all the diboranes at different temperatures gives boranes of different combination. The second equation, you are getting B4H10 at 373 Kelvin, and the same 373 Kelvin in the third equation when it is taken in a sealed tube. When the tube is completely closed, you are getting a different product, that is B10H14 plus 8 hydrogen you are getting. And if you see the fourth equation, again diborane, when the temperature is raised to 523 Kelvin, it gives another borane, that is B5H9 plus 6 hydrogen. Similarly, at 523 Kelvin, the next equation, it gives B5H9. And the last equation, if you see at red hot, when the temperature is very high, the diborane gives boron separately and hydrogen gas separately. That is, at red hot, it dissociates into its components, boron and hydrogen formed. The next reaction is, diborane reacts with water and alkali to give. In the first case it gives boric acid H3BO3, and the second case it gives metaborates sodium metaborate. Formula is 2NaBO2 is the product. So again see this reaction. Diborane reacts with water and gives boric acid, and the same diborane plus 2NaOH plus water gives metaborate, that is NaBO2 plus 6 hydrogen gas. And the next reaction is action of air. At room temperature, pure diborane does not react with air or oxygen, but in impure form it gives B2O3. See the equation down. B2H6 plus O2 gives B2O3 plus 3 water molecule, and it liberates a large amount of heat, that is delta H is equal to minus 2165 kilojoule per mole. And the next reaction is hydroboration. What do you mean by hydroboration? That is, diborane adds to alkenes and alkynes in ether solvent. Once again I will repeat. Diborane adds on to alkenes and alkynes in ether solvent at room temperature, and this reaction is known as hydroboration. See the equation down. B2H6 plus 6 RCH double bond CHR. So it is an alkene. Since you have double bond, it gives a compound 2B RCH single bond CH2R thrice. So this is what you call hydroboration. And the next reaction with ionic hydrates. Diborane reacts with metal hydrates. For example, here given lithium hydride and sodium hydride in the presence of ether and decline. Both gives metal borohydrates. So in the first case, lithium aluminum hydride B2H6 plus 2LiH in the presence of ether gives 2LiBH4, lithium borohydride. The next reaction, B2H6 plus 2NaH in the presence of decline, it gives 2NaBH4, that is sodium borohydride. And the next reaction is with ammonia. A interesting compound you will be getting here. Just please listen. A very important equation. When treated with excess of ammonia, a temperature is very low, that is minus 153 Kelvin, diborane gives diborane diammonate, one compound known as diborane diammonate. See the equation down. B2H6 plus 6 ammonia NH3, temperature is minus 153 Kelvin, it gives 2B2H6 dot 2NH3. Otherwise, B2H6 plus 2NH3, when the temperature is raised high temperature and the compound is taken inside a closed vessel, you are getting an interesting compound known as borazole, otherwise borazine, and this compound is known as inorganic benzene. The formula is 2B3N3H6. See the structure, it has a similar structure as a benzene ring, that is 6-sided figure. In all the cases, one nitrogen, one boron alternatively attached, and each one is attached to another hydrogen atom. So you are having an hexagonal shape just like benzene. That is why it is known as inorganic benzene. This borazole is known as inorganic benzene. Yes, time ಆಯ್ತು